Hello and welcome back to another video for Learning Java for Complete Beginners. In this episode, we're going to go through functions, which are quite an exciting topic. Just to recap on the last episode, we did for loops, while loops, and switch statements. So let's dive right in and have a look at how functions are created in Java. Um, with Java, you're likely to see them called methods as well. Those two words are quite interchangeable throughout different languages. Just as a generic term, I call them functions, but they can also be referred to as methods. Generally, I see methods as functions that are associated with classes. So this is the first time we're going to also talk about scope as well. So that here we see public static void main string array of arguments. Essentially, this is a method here or a function, and this is the main function. So what this is used for is the entry point for your application. This is a very commonly used one because it's the entry point. You have to have a main function, but we're going to create our own function under here. So it can no longer be within the code block of the main function because we're defining a new function. So it can be in the class. We'll go with classes later. We'll talk about them later. But it can be within this code block. But notice how this function here has its own code block. Well, we need to be outside of the scope of that. So firstly, I'm just going to type out the syntax like I normally do of a particular function, and then we're going to break it down and see what's happening. So firstly, we need a scope and then what it returns and then a name for the function, some regular brackets, some curly braces. Then we need to think about what this is going to do. This function is essentially just going to add two numbers together. Now we take them in here. Let's just say int x, int y, and then here return x plus y. Now let's quickly break this down. What is happening here? So firstly, we are outside the scope of this function, meaning we are defining a new function here. And this is kind of like when you declare a variable, we're just declaring the function here. We're not actually using it for anything at the moment. So private means it can only be accessed within this particular class. If you have no scope there, that is automatically set to protected, or you can be explicit. And that means it's package protected, meaning anything in the same package can access this particular function. And then you can also have public. Um, I will come more onto these a little bit later on. For best practice, you want to make things private. And when we get into things like interfaces and writing clean interfaces, we can discuss the use of public functions and also static functions and things of that nature. For now, we're just going to cover what a basic function is. So we're going to keep this private, meaning it can only be accessed within this class. One thing I did forget to add in here is it also needs to be static. Static means that this particular function slash method can be used without instantiating the class as an object before using that particular method associated with that class. That might sound confusing to you. You're like, what's a class? What's an object? How do I instantiate it? At the minute, we're not going to worry about this too much. We're just trying to think about what a function is and what it can do for us. But know that without instantiating a main object, which would not really make much sense, we cannot use this unless we add static in here like that. So that is the use of static, and we will cover static things a little bit more in depth when we do get onto objects. Um, the next portion is int here, which is the return type. So we've got the scope, which is private. We have static, which is an optional keyword. In this instance, it is needed, but occasionally when you have a object that's been instantiated from a class, you wouldn't need it to be static. You could just call upon that particular object and then dot add, and that gets into object-oriented programming, which will be discussed later. But for now, we're not worrying about that too much. We're just going to add static here so it works for now. Int is the return type. So whatever this returns, notice this return keyword here. We'll get onto that in just a minute. But know that you can assign something to this method. You can create a new variable and that new variable will have to be an integer because that's what this returns. This is what this spits out at the end. Okay. In the brackets here, we have integer x and integer y. These could be named anything you like. And they are just used within here. So let's actually take a look at a working example. Oops, what have I done here? Return x plus y and change that to x, change that to y. So let's take a look at a working example here. So if we say integer added numbers equals add 2 and 2. Now let's take a look what we're saying here. We've seen this before. We're just declaring a variable here, which is an integer. That's its address, variable name, added numbers, and we're setting it equal to this function here. So what does that mean? What that means is it's calling this function add, and it's saying, right, okay, we know add returns integer, so this has to be an integer, and we're passing in 2 and 2, and 2 replaces x here, and 2 replaces y here. And we are then returning whatever x add y is. So in this situation, we'd expect 4 to be returned. If we print out if we print out the system.out.println, and if we print out added numbers, we are expecting to see 4 here. Let's have a look. 4, there we go. So let's just talk a little bit about this as well. So notice that this is in the main method here, and we are declaring a variable in here, and then we are calling this function that we've defined below. We've defined this function already, so it goes, okay, so add, what is that? Okay, it's a static method that returns an integer. So we're going to return an integer here, so that should be an integer, correct. Takes in 2 integers as parameters. These are called parameters. Here in the regular brackets, so they are just placeholder values in here that can be replaced with anything you like as long as they're integers, clearly. And then it adds them both together, x plus y, and returns them. So it spits it out into added numbers, and then added numbers contains whatever the return of this is. Here we are, and then we print out the added numbers variable. What we can do is we don't have to do that. I think we can just do add 2, 2. And then if we run that, we should get the same result here. There we go. You don't have to print it as a variable. You can just print the function's return type. So, okay, you might be asking yourself, what is the use of this? Because currently we're just printing out the number 4, and we could just print out the number 4 here like so. Run this, get the same result. Or you could just even, if you really wanted to know the answer to this, 2 add 2. This might print out 2 lots of 2, but seeing as they're both integers, it should print out 4. There you go. So you might be wondering to yourself, so what's the purpose of this function? Like it seems kind of irrelevant. Well, you'd be right in saying that, because this function actually doesn't do all that much. It just adds 2 numbers together and returns it. Where the functions really shine is when you get larger, more complicated pieces of code that need to be used on multiple different variables or objects or whatever that function does. It needs to happen multiple times. Instead of rewriting the code repeatedly, you can store it in a nice function with a really easy to understand name that just does it for you. You can then remove that complexity from your head and know that it's done correctly, and then work on everything else at hand. So it's a way of breaking up your code into smaller, easier to manage blocks. An example of something more complicated is if we have a similar function here. We'll call it private static, again, as explained earlier what static is, int, and we'll call it custom function. This is a terrible name because it doesn't say what it's doing. It's just kind of a random name for it. But there is nothing we're trying to do. This is just a random assortment of calculations it's going to do in here. We're going to take in 2 numbers again, so integer x and integer y. This time What we're going to do though is something more complicated than just adding them together. First, we will add them together, and to do that, we actually need to make a variable inside this function that is only accessible inside this function. So I'm going to call this integer z equals x, plus y. Okay. So in the case of sending in to this function 2 and 2, z will be now 4. Okay. What we then want to do is times z by itself. Okay, so integer z equals z times z. Oh, why is that not working? It's already defined in the scope. Yep, so we don't need to redefine it there. We're just assigning it. Cool. Then we are going to add 10. So z plus 10. Z plus equals 10. And then we can say z equals z over 2, z divided by 2. There we are. And then what we're going to do is return z. Now, as you can see here, this might be something that needs to happen to some data somewhere along the line to get it into the type of data you want, or to work out some complicated maths based on that, or whatever it might be. There could be a lot of kind of intricate, delicate code, and if you wrote this out every time you wanted to change a variable into the new variable that you're after, it would get a little bit complicated. Or if you wrote a function that does that for you, and then every time you want that to happen, you just call that function and you know it does that correctly. You don't have to think, oh well, then it times is it, and then it adds 10 and it divides by 2. You just think it's going to end up as the right thing. So that's what it's used for. And again, if we pass in 2 and 2, you could probably work out in your head here what would happen. However, if we pass in 2 and 16 and 48 and 91 and a bunch of other numbers, let's just try that and see what happens. So if we in here again say custom function, and we pass in 2 and 16 like I said, and again we're going to print out some more stuff. Let's say 45 and 91. So the issue might come when this divides it by 2 and it's not a floating point, but we'll see what happens. Okay, so we get 167 and 9253, and we can just repeatedly use this custom function with as many different integers as we want, perform all these complex calculations on it, and we only have to write this code once. So that's where functions really shine. They remove complexity from your main source of code. They make it easier to understand and read. You don't have to store all this complexity in your head for when you're writing your code, and it's reusable. It's really easily kind of reusable. You just call it where you need it, and that is the use of functions. I'm now going to set a challenge, quite an easy one. It's going to be using a function. I'd like you to design a function that takes in a integer and returns a boolean, and oh sorry, not a boolean, a string. Sorry, a string, not a boolean, a string. And you are going to decide within that function whether the integer that has been passed is odd or even, and return odd or even if whichever the case may be. So if I pass 2, it'd return even. If I pass 51, it'd be odd. Example. Have a go at that. Try and remember some of the things we used earlier. Try and remember some of the operators that we used. If you need to look them up again or go back to the video, be my guest. That's fine. But definitely you will need a very particular operator, or you might come up with your own way of doing it. That's fine. Yeah, so look up the operators, kind of figure out what needs to be done. You can use if statements, switch statements, any kind of loops you might think you need. Try and incorporate everything we've learned, and just create a function that returns a string that says odd or even based on the input, and try and get that working. Feel free to pause the video now. I'll give you a few seconds to do that, and then I will show the solution. Okay, so I'm going to write this live, so a mistake may be made here, but that should be okay. Static int, odd or even. Let's say we're taking an integer. Um, okay, so we need to determine whether x is odd or even. So the first thing we need to do is modulo it. If you remember, um, sorry, yeah. So we're going to have a switch statement as well. So first things first, we need to say z equals, sorry, x modulo 2. Okay, so integer x, z, sorry. So what this is saying is we have an integer z here, and it's equal to x divided by 2 remainder. So if if x is 4, the remainder will be 0, so x will be 0. If the remainder is 1, then it's going to be odd because it will be divisible by 2, but the remainder will always be 1. So if we put that into a function here, if you don't understand this, try and think of it as divide anything you want by 2 and give me the remainder, and that's what's stored in x. If the remainder is 1 ever, that means it's not been divisible by 2 and there's some remainder left over. Therefore, if x is ever 1, it's got to be odd. If x is 0, it's even. So what we can do is we can say an if or a switch. I'm going to use an if. If z um, is sorry, we don't even need this intermediary kind of variable here. That's kind of a waste. It was good. It was good to show that though. We can say if x modulo 2 is greater than um, sorry, is equal to 1, return, and that needs to be a string because we're not returning an int. Returning a string. There you go. Return odd. Else return even. Okay, so what's going on here? Pretty simple. We're taking in an integer, x. Um, x modulo 2, as I explained before, if it's equal to 1, it's going to be odd. Else, every other time, it's going to be even. Let's try this out. I'd like to see if this works with some kind of wacky numbers as well, like negatives or 0. So let's try that out. System dot out dot print line, and then we can say odd or even. What kind of number shall we start with? Let's start with a basic one, and let's say 4. So we are expecting even. Sorry, here even. There we are. Let's try 5. Two basic numbers. Odd, correct. Let's try 99, just for clarity. Again, odd, correct. Let's try 0, hoping even. And let's try -2. Even, okay, -1. Even, okay, -3. Okay, so it's always even because I think it will be a minus number is the remainder, which means it's not equal to 1. Okay. One thing I haven't taught you guys, which is really going to be handy and useful, is in an if statement, if you want to add an and or an or, so you can say if this and something else is true, do this, and you can say this or something else is true. So the difference being, let me write it out and I'll explain. X modulo 2 is equal to -1. So this is an or. This is 2 bars here. This basically means this is true, it goes in straight away. If this isn't true, it goes, okay, that's not true. What about this one? Oh, this is true, then it goes in there. As long as one of these is true, this will happen. That's what this means. It saves you writing out a bunch of if statements. You can also have and, which is double ampersand, like so. What that means is both of these have to be true. If one of them's true, then it's not going to work. It's going to skip this. They both have to be true. In this case, we just want an or because we don't really care which one it is. If it's not 0, then it's odd. Which, in fact, looking at this from a software engineer's point of view, you'd probably want to say x modulo 0 if it's not equal, sorry, modulo 2, what am I talking about? If it's not equal to 0, then it's going to be odd. Everything else is going to be even, okay? So let's try that again with -4. We're expecting that to be even. Okay, no, that won't work because of negative numbers actually. So let's, again, I'm doing this live, so apologies. Yeah, so we want this or statement in here just to kind of clarify that if it's -1, that's okay as well. I'm not really sure how it passes negative numbers, but we're about to find out. Okay, no. No, no, no. No, no, no. I don't think this is going to work. Oh, it is. Okay. Oh, okay, it is. Okay, yeah, that's fine. Okay, so it does work. If it's not equal to 0, then we have odd, basically. Yeah, that works. Okay, cool. So what we're saying here, if x modulo 2 is equal to 1, or for any negative numbers, -1, it's odd because the remainder, it always has a remainder if it's divisible by 2, and we know that all even numbers are divisible by 2. So therefore, it's even. Okay, that's how that works. Hopefully you guys got that right. That's all I'm going to cover with functions today. I hope you enjoyed it. If you have any questions, pin them in the comments and I'll try and answer them best I can. Next time we're going to move on to even more juicy stuff. Again, this is no nonsense, trying to speed through this stuff. You kind of only need to see this stuff once, and then once you start writing code yourself and seeing it in other people's code, it will just become second nature to you, to a point where you can kind of, if I was to show you a different version of this right now, you'd be able to understand it. There are some things I'm missing out, like I missed out this or and when we come to use them, which I'm sure anything we need to use we will in this course, I will explain them completely if I haven't before, so don't worry about that. But that's functions for now. We can get onto classes and objects next time. That's a huge piece. And then we can start talking about object-oriented programming, what that means, how objects are used, how they're really useful, and from there it gets really exciting. We can start looking into kind of inheritance, polymorphism using abstract classes and in interfaces, what interfaces are used for, what's the difference between an abstract class and interface. Um, we can start talking about a whole bunch of stuff. Then we can start talking about what Java 8 Plus adds to the package, and how streams work, and just making your code really nice and clean and well refactored. So there's a lot still yet to come. And then at the end, we're going to do a huge project together, which I will sit and code along with you and show you each of the steps. But again, this is basic stuff. This is functions. Watch this as many times as you need to understand the basics. And I hope you enjoyed. Subscribe for the next one, and I'll see you then.